and as simple as I can. It should be noted that this person who is recording the video is also the member of the class. He is not a separate videographer. So that he himself should also attend it carefully. In this brief session, I would like to clarify what you might not have understood in the very long sessions. Digital signal processing is derived from discrete time signal processing, which is further derived from continuous signal processing. When we talk about signal processing, we are concerned about some particular physical parameter. There has to be one source which can generate this parameter in a particular manner. There has to be a system which will respond to this generated parameter, and there would be some parameter, most probably the same parameter, available at the output. In most of the cases, the parameter is considered with respect to time, or in general, a signal is considered to be a time signal, means a parameter versus time. As regards to applications in electrical engineering in general, or electronics engineering as it is popularly known, the signal processing is mostly connected with the voltage signal, because we find that we are more close to voltage parameter than any other parameter. And a simple passive circuit comprising of, again, resistor and capacitor, which are readily available, can be thought to be a system. A voltage signal generator is a voltage generator. System is an RC circuit, and at the output we can record it using an ADC, or we can see it on the CRO along with the input signal. So essentially, we work with a two-port system for voltage input and voltage output. Right? We work with a two-port system for voltage input and voltage output, which can be listed as
अपना भी हमें
Let us welcome these four students who were absent for the test but have made it a point to come for the lecture, because they are not mark savvy but they are knowledge savvy.
So one more.
In explaining, I would like always to have a very simple system where we are having one simple RC network. This is the simple most two-port network, which is non-trivial. We can have a trivial network of the same points and output, or a simple resistor-based attenuator, but that hardly comprises the system. And we also choose R to be equal to 1 and C to be equal to 1 for further simplicity.
Record.
Then and I am very much sure that an individual who understands this circuit well would be in a position to understand any other circuit. The input voltage in T is a voltage signal, and that can be fed from a signal generator or that can be output from any other system. And we want to find out how the circuit behaves and what output it delivers. Since we are having the element of capacitor which does not provide a linear relationship between voltage and current in themselves but provide a linear relationship in differential domain, the things become complicated. Then there has been a technique which is suggested to simplify the things, but since its details are not appropriately shared with the users, the simplification process itself remains complicated, and rather than simplifying the contents, takes us into a further complex domain which needs to be avoided. So we want to clarify that to the maximum extent possible today. This theme being useful in continuous signal processing can be easily exported to the discrete time or digital signal processing. It is difficult to write a simple equation for this system now because the differential terms coming into picture, and we are required to have a differential equation which itself is complex in nature. Since the capacitor has got a differential relationship, prima facie it seems that the differential equation is unavoidable. However, by considering the properties of some functions, we can think of finding out such a function wherein the differential operator will reduce itself to a simple algebraic operator. We are in search of such a system where we want that the differential or integral operator should simplify itself to be a scaling operator. And really and fortunately, with very complex mathematical science development in the field of calculus, trigonometry and complex numbers, we have such signal, even though we may not understand its exact significance unless we pay our own attention and try to interpret on our own, because classical literature available in this field doesn't clarify that. Whatsoever may be the purpose of the literature writers, the ultimate sufferer are we, wherein means it is presented in such a manner that the beneficiary turns out to be a sufferer. The complex number domain and exponential domain, what we are doing is, since it provides us a good number crunching facilities, good mathematical manipulations, we are using them. So from that regard, I am very much sure that everybody of you must be knowing e raised to j theta as cos theta plus j sin theta, where e raised to j theta is a single representation in polar form of a two-dimensional complex number, and if that can be extended to e raised to st. So e raised to st is a very wide class of signals, is a two-dimensional in nature. So e raised to st cannot be plotted on a single axis, but it needs to be plotted in a 2D plane. So e raised to st means I have simple signal, say sin t or sin omega t. It will have a single value at a given time, and it can occupy itself anywhere on a given line. So sin omega t, cos omega t, e raised to t, t raised to n, all these are one-dimensional signals, and they can occupy a single point on a given line. That is called as the reference axis. But e raised to st, where s is equal to sigma plus j omega, sigma being real part and j omega being imaginary part, considered by well aware of the significance of the imaginary concept, because it is just used to have two-dimensional mapping and nothing more. So from that point of view, e raised to st can occupy itself anywhere in a given plane to which we are having two mutually perpendicular, popularly known as orthogonal axes, as reference axes. Once we are well aware about the plotting of e raised to st, we are aware also about the manipulations with e raised to st. We can displace it either in the same direction from origin, or we can displace it at any arbitrary position, or we can rotate it on a circle. Means if we rotate on a circle, its amplitude remains fixed. If we rotate it, if we displace it on the same direction, then its direction remains fixed. Or if we rotate in arbitrary way, both do change. Now, with the very much popular properties of differentiation of exponential signals, we find that d by dt of e raised to st is equal to s into e raised to st. Therefore, we have got a unique function ft which is equal to e raised to st as such function where f dash t is equal to s into ft. So that's an integration of ft comes out to be ft upon s. So we are exactly reaching there, which is our destination. What is our destination in this entire discussion? Since the what was the very much problematic thing in the computation? That was the differential treatment of the capacitor to these electric signals, and because of this differential treatment, we were having differential equations about which we were not comfortable. Therefore, we wanted to convert the differential equations into linear equations. For that purpose, we wanted whether is it possible for me to have the differential relationship to be as good as a linear relationship. And as such, I have found a signal which is wider, e raised to st. For sigma, if e raised to st is have multiple parts, if sigma is 0 and I have some omega non-zero, then I get a signal which rotates on a circle. If I get omega is 0 and sigma is non-zero, depending upon sigma, it either exponentially increases or exponentially decreases. And if I have got both non-zero, sigma positive, then I get a rotating phasor whose length increases like this. And if I have sigma negative, then rotating phasor whose length reduces. Omega positive anti-clockwise, omega negative clockwise. So I can have e raised to st to change its position on the 2D plane in a particular manner, and its derivative and integration result into its just scaling, and therefore I can write a simple equation. So what equation I can write now? VOT. Now with this the concept of impedance for capacitor comes. How the concept for impedance for capacitor comes with this? The concept for impedance of capacitor comes like this. I have got Vt and I connect a capacitor. What is It? It is equal to C dVt by dt. And now if my Vt is e raised to st, then dV by dt becomes s e raised to st. So if Vt is equal to e raised to st, then dV by dt becomes s e raised to st, and I get It as Cs into e raised to st, which is equal to Cs into Vt itself. And then if I take a ratio of Vt upon It, I result with Cs or Cs. This is the impedance of the capacitor, and if we proceed in the same manner, I get impedance of the inductor as S inductor. And once this is very clear, I can use it directly in the equation, directly in the system, and I can get the output. So if I have C equal to 1 and R equal to 1, and if my Ft is equal to e raised to st, what will the output? What is the output in this case now? R is 1, C is 1, means its impedance is 1, its impedance is 1 upon S. So the output will be 1 upon S upon 1 plus 1 upon S into V into E. This is provided if my input is e raised to st. If my input is e raised to st, output would be like this. In general, you can e raised to st, you can make it to be a e raised to st also, where a can be amplitude. But right now we are making it 1. So what will happen? It would be 1 upon S plus 1 into But now there is a big problem. What is the big problem here? What is the big problem? The problem is in the signal itself.
Sir, signal one dimensional voltage and S two dimensional.
No, our very assumption of connecting V in T as e raised to st to the two-port network input is wrong. The input is a voltage, and
Voltage
1 dash at port 1 dash, the point 1 can have some voltage with respect to point 1 dash, and that would be a single number. Voltage is not two-dimensional. If ever somebody is treating voltage to be two-dimensional, it is completely wrong. Amplitude and phase are not the reflections of two dimensions of a voltage. Voltage is always a one-dimensional quantity, wherein at any given point of time, one point can possess some voltage with respect to other point. That would be a single number plus something or minus something, not more than that. So connection of e raised to st, which is a two-dimensional voltage, is not appropriate. That remains a simple assumption. However, with well aware about the fact that e raised to st is not realizable, still there is a scope with which we can have meaningful conclusion from hypothetical discussion. The hypothetical discussion does not conclude always hypothetically. There can be a significant and meaningful conclusion. We can proceed how? Number one, even we can take help of superposition theorem. What superposition theorem states? If I apply two sources simultaneously, then the output would be same as the summation of two independent outputs with one taken at a time. Therefore, we should now, what is the use of e raised to st? Use of e raised to st is that it provides us the differential relationship converted into scaling relationship. Therefore, we want to use that. Merely because I cannot realize e raised to st and apply it between 2 points, it doesn't mean that that entire idea should be dropped out. I would be still using it. But what I should think of, I should try to make use of superposition theorem, and I should have two different signals. S is a now parameter. So I can have V1t as e raised to S1t and V2t as e raised to S2t. And I can say that V in t is equal to summation of V1t plus V2t, with both V1t and V2t may be non-realizable, but Vt may be realizable if it works out to be one dimensional. And it really happens so if S1 and S2 are complex conjugates of each other. In that case, their summation is one dimensional. For further simplicity, we can take sigma to be 0 and only concentrate on e raised to j omega t. So if we have got V1t we have got V1t is equal to e raised to j omega t and V2t is equal to e raised to minus j omega t.
सर पण सुपरपोजिशन फक्त लिनियर सिस्टीमलाच येणार सर ही लिनियर पण कॅपॅसिटर जोडलाय सर लिनियर नाही जोडलं.
See, connection of capacitor is a linear system. Capacitor, otherwise there would not have been a subject like linear circuits. Diode is not linear. Transistor is generally not linear. There is a special region of linearity. So, if I now have V in t as V1t plus V2t, then I can have VO1t is equal to, you can find VO2t, you can find what will be VO1t. So what happens is, means there might be a ultimate confusion within you that the phasor, when I have phasor is two-dimensional. What is the concept of one-dimensional output from it? It's projection. Actually, then who takes the projection? I don't know whether you do have a self-talk. If you do have a self-talk, then these questions must have prompted to your mind that all right, that phasor is there, we accept. Rotating with omega plus omega like this, minus omega like this, that is also all right. If projection on the diameter is sinusoidal, that's also all right. But who takes the projection and how? Actually, there is no projection, but one phasor like this and other phasor like this, when they add together, it always, their addition is always on the x-axis, because their imaginary components are equal and opposite and they do cancel. Therefore, what will happen now is, if I apply the input like this, then what will be VO1t?
आधा घंटा होता
What will VO1t? VO1t. What it would be? It would be 1 upon s plus j omega is a special case of s e raised to st where s equal to j omega. So VO1t would be equal to 1 upon j omega plus 1 into V1t. Similarly, VO2t is equal to what? 1 upon minus j omega plus 1 into V2t. That is equal to e raised to minus j omega t upon 1 minus j omega.
खत्म हो रही है 2 घंटे बाकी है अभी
It is really unfortunate that your concentration. It is expected that the concentration should exponentially fall down, but depending upon the contents of the session, there has to be some decaying constant for that falling down, and for such discussions, the decaying constant should be such that the fall should be very slow speed, and it should maintain at least 90% of concentration level at the end of 1 hour. So what is the answer now? What is the answer here? It is 1 minus j omega into e raised to j omega t plus 1 plus j omega into e raised to minus j omega t upon 1 plus omega square. Is it correct? What is the answer then for that?
मेरे 50 सेकंड में
j omega t plus e raised to minus j omega t. And what happens with this?
ये होगा ना
Plus j omega into bracket
बंद करें आप बंद कर दें
बिल्कुल